This game is fucking hard, I gotta tell you. Well, hello to my favorite people on the planet Earth. How's it going, guys? In the last episode, we coded the base of a Flappy Bird game, and in this episode, we're gonna turn it into a real Flappy Bird game, man. We're gonna make this thing fly and maneuver between obstacles. So, first of all, you need to download this Flappy Bird image PNG file that I'll leave a link to this in the description so you can easily download it. So go download it now and we'll go do the rest of the stuff. Yeah. Okay, after you downloaded that PNG file, what you want to do is to make a folder in your project folders and type res as the name. So it's the resources folder. The Hex engine is gonna recognize this and grab everything that is in it. So place the fp.png sprite in this resource folder and place anything that you want to use in your game, any sound effect or stuff like that, just in the resource folder. And when you want to use this, you just go to our tile specification over here. So right now it's tile.flum color and something. I guess it was blue. I don't really remember that. We need to change this, so we don't want it from a color anymore. We want it from a resource. So what we do is to first import hxt.res at the top. So go ahead and import that, and after that, instead of tile.fromColor, we just say res resource dot, and the fp just pops off. So fp and then dot to tile. So we turn that image, PNG image, to tile. After that, we now have that PNG image. We set the pivot to the center of it. So change this if it's not currently like this, with written with the width and the height. Just change it to this, and after that, rename the game object that was I guess it was GO to Flappy Bird. Rename the game object to Flappy Bird and all of its occurrences to Flappy Bird, so you can recognize it and you can manage your code so much better. Your code will be so much better if you change this name. Yeah. So after that, we actually had a rigid body on this Flappy Bird thing. So here you have to have new rigid body or something like that. I want you to remove that for now and define another rigid body up here. So you want to say where RB, specify the type to rigid body, and here you want to say RB is equal to new rigid body. We want to attach it to our Flappy Bird, and we want it to be affected by gravity, so we say true as to be affected by gravity input. So now we have the rigid body saved in a variable and we can easily access and modify it. When you want to use the resources, you have to go to your main function that is a static, and before making a new main application, main class, you want to call res.initEmbed. So it embeds the resources with your application, so you can use any resources that you want throughout your code. So I'm gonna build it now, and now it should be working. Ta-da! Okay, now we have a Flappy Bird that jumps. Okay, if you've seen the game, when Flappy Bird jumps, it tilts its head upwards, and when it's falling, it tilts downwards. So we want to first add that effect to our game. So what we want to do here is to go to update, and we want our Flappy Bird object that rotation that obj that rotation to move, to change, and we want it to decrease when it's jumping, and we want it to increase when it's falling. So we add to it our RB dot velocity dot y times a very small number, maybe like even smaller. Okay, now when our Flappy Bird is falling, the y velocity is gonna be positive, and it's gonna rotate clockwise. And when our velocity is negative, it's going up, it's jumping, it's gonna add a negative value to rotation. It's gonna rotate counterclockwise, and that's what we want. So if we save this and go to our browser, refresh it, it's gonna have a very nice tilt to it. So there's that. Right now, a strange thing happens when you go off the screen. So when you go off the screen, your game object just disappears. There's no game object anymore. So it's a feature that I coded into my ECS because the nature of my game that I made with it, and we have to just delete it because we don't want our character to just disappear when going off the screen. So what you want to do is to go to ECS, sprite, and here you can in the update function of sprite, you can see something that I commented it with for the test game, remove if you're coding a new game. So it simply says when the sprite is off the screen, just delete it, just kill it. We don't want our bird to be killed. We love our birdie, so we're gonna remove this part of our code and save it and build it again. So now if you refresh and go off the screen, we're gonna come back again. Okay, the next thing that we want to do here is to add some obstacles. Easy peasy, right? Just add some squares that you learned how to build from last episode, and make those squares like green, and add rigid body to them. Don't make them affected by gravity, and make them have a velocity to come to the left gradually and go out of the screen. But when they go out of the screen, we don't want them anymore. So yeah, go ahead and try to code it yourself, and then after that come back to the video and see how I do it. That would be a very good exercise for you. Okay, I'm gonna assume that you did that, or didn't, whatever. What we want to do here now is to add another function to our application. So right here I'm gonna say private function add obstacle, and in this function we want to add an obstacle. How so? We would want to say where obvious tile up. Basically, our obstacles are made of two parts, an upper square and a bottom square. So these two together just have some kind of hole in them, and our bird has to maneuver through that hole. So we have var obvious tile up of type tile. We have var obvious tile bottom of type tile. We want both of these guys to be made from a color. The color is green, so it's 00FF00. We want the width to be like what would it be? What would be good for this? Our birdie is of width. It has a width of, I guess, 50 pixels. So maybe make the width 100 and make the height, make it very high, like 800. And yeah, that would be it. And then obvious tile bottom is the same, exact same thing. But the difference between up and bottom is in their pivots. So down here we're gonna say obvious tile up dot dx is obvious tile up dot width, and make it negative. And we want the pivot of the upper part to be on the bottom tip, and we want the pivot of the bottom part to be at the upper tip of it. So, and after that we just make the game objects and add the sprites to them. So okay, so this is it for now. We added some sprites, we added Razor Buddies, and after we called the new Razor Buddy that we instantiated, we called dot because it returns a Razor Buddy dot velocity and set it just right away to -100 on the X, so they're gonna go to the left. Okay, but what do we want to set our X and Y of our obstacles to? That's a pretty hard question to answer, so we're gonna just guess something, test it out, and just see what happens and what works the best. So the X of it, we want it to come from out of the screen, so it's gonna be std.width. So both of them. But the Y value of them for the upper part is gonna be in the middle, or wherever it is. Let's say it's in the middle right now. In the middle, minus some offset, so it's gonna say s2d.height minus some offset like 100, and the bottom part is gonna be in the middle plus some offset, so it's gonna be s2d.height divided by 2 plus 100. We forgot to call our function, so yeah, call it after our initialization. So at the line at the end of our initialization function, just add it there. We have to set this to minus height of our obstacle tile, so it's gonna be at the bottom tip of our obstacle. The pivot's gonna be there, so if you add a minus, We build our application again. Go to our browser. There it is. We have an obstacle. Yay! How hard is it to? Man, that's hard. That's hard. Okay, so we wanna regularly add obstacles to our scene. So what we want to do here is to set a timer and add obstacles, let's say every 1 second. So to do that, we want to add another variable time of type float. This variable is gonna hold time. Yeah, add another variable, spawn OBS timer, and so if we set it to 2, there's gonna be an obstacle spawned every 2 seconds. I don't want 2, I want like 5, so maybe 3, I don't know. It's very slow. Our obstacles are very slow. So yeah, that's that. And after that, we want to go to our update function. Where is our update? Okay, there it is. And here we want to add to the time the delta time. And after that, check if the time exceeds our OBS timer. And if that's the case, set the time to 0, reset it, and add an obstacle. If you want an explanation about how this works, delta time is the time difference between the last frame and this frame, the last update and this update. So every time we update, we add the time difference between those updates. So gradually we're building up time. So let's say our update gets called every half of a second. So we add half of a second to time every half of a second. So it's really our seconds time. So whenever our seconds exceed the amount of time that we wanted our timer to get called on that time regularly, we just call our function. I don't know what it just said, but I hope it. Also, we have to initialize our time to 0. So right now it's changing, and whenever it exceeds 3, we're gonna have a new obstacle. Dude, this game is gonna be so hard to play. Right now our library, our ECS, only has circle colliders, so we cannot cover a square. Okay, to add some colliders, what we need to do is to, first of all, we need to add a collider to our Flappy Bird. So it's a circle collider, but with a radius of 50. So we say new circle collider. We'll give it the game object, Flappy Bird. We'll give it the center. It's a new vector 2. We want it to be totally centered, so it's 0, 0. And we get the radius. Jesus. Give the radius a value of 50 because our bird is 50 pixels wide and 50 pixels high. 50 pixels high. Let's make it a little bit smaller, so it's gonna be easier to play. And after that, we need to add colliders to our obstacles. So right now the height of our obstacles is 800. So we can add 8 colliders with radius of 100 to cover it all. To do that, we're gonna write a for. Okay, to write a for loop, we're gonna say for I in 0 ... and it's gonna be the end, which is 8. And after that, we want to add colliders, right? New circle collider on the game object. Up go. This part is important. The center is important. So new vector. New vector 2. We want x to be centered, so 0. We want y to be 50 times I plus 1 maybe. So yeah, and after that we want the radius to be 100. Could copy that for, and just repeat it for the down go, the bottom part of our obstacle. We want our, okay, that should work for now, but we want these to not be colliders but triggers. So what we want to do here is to define a variable collider of type collider, set equal to these guys, and after that just remove this bar. We're gonna copy it again. After that we want to say collider that is trigger, oh my god, is trigger equal to true, so make them trigger. And what is wrong with this? Okay, and you want to add an event, so whenever it's triggered by this, whenever our birdie goes into this, we want to call some event, some lose event. So it's private function lose, and we want to add this lose function to that collider. So say collider dot collider event dot function list dot add, give it this lose effect, this lose thing, and our item has to get a collider as the input, our function. So we can now safely add that. Okay, now we copy this loop for our down go. Damn. Okay. But there is something we have to take care of here. The centers of these colliders have to be changed because our pivot points of our downer part and upper part are different. So for the upper part, our pivot point is in the bottom, is at the bottom tip. So we want the center of these colliders to be adjusted to that. We want minus 50 here. So it is building up, collider here, collider upper, collider here, a collider on top of that, a collider on top of that. So it's going up, it's going to be minus. For this one, it's going down, it's going to be, this is not the right formula. We want that offset and we want it to go change 100 by 100 every time. You make it minus, and yeah, this should be fine now. So for 0, for the first collider of our upper part, it's minus 50. This is gonna be 1. We have to remove this bar too. This is going to be 0, so it's going to be minus 50. So it's going to be minus 50 with the radius of 100. The focus for the second one, which is 1, is going to be 1. And it's going to be minus 100 plus minus 50. It's going to be minus 150. And it goes on and on for 8 iterations. It takes care of everything. So, yeah. Actually, instead of 100 for the size of the collider, you have to use the number 99, because 100 means it's constantly colliding with its other neighbors. So use 99 and you'll be fine. 99 instead of 80. Okay, 99 is good, but 100 is not working. My bad, writing the ECS. Okay, now that it's working, let's code the lose function. When we lose, we want to stop everything. So, how do we do that? We define a variable up here. Variable. Pause. Of type boolean. We set it to false by default. And in the update, if it's not paused, if our game is not paused, we update everything. But if it is paused, we want to just stop everything at their places. So here, when we lose, we set the pause to true. Now if we build our game, go to our application. Now if we hit one of these obstacles, we're gonna be stopped. Let's try hitting. Oh my god, that looks cute. Okay, right now what's missing is the fact that we need to just move these obstacles up and down. So the last part would be adding an offset to these obstacles and giving it a random offset. So now in our add obstacle method, what we do here is that we set it in the center of the screen. So we want to give it a random number instead of the center of the screen, but in the range of the screen. So to do that, we need to install some library. So we type hexlib install random. That's right. We need to install the random library. It's not included in it. And that's why Hex is so lightweight. It doesn't have the necessary stuff in it. So here, so now that we installed the random library, to use it, we need to go to our compile.hxml, and in here we need to include it. So we would say lib random, and if we get back here, we can generate random numbers. It's random dot float, and we want our float to be from 0 to the s2d dot width. Actually, not the end of the screen. We don't want it to be spawned right here, so give it an offset of 200. Since we need the position of both of these guys be the same, we can add a variable here, rnd of type float, and set it to our what happened? Set it to our random number. Come on. And then we use it here and here. make it a little bit higher, like 1,000. It's not gonna make a problem with the colliders, so don't change anything, just make it a little bit higher. And don't make it 0, make it 200. Height minus 200. So this game is fucking hard, I gotta tell you. It's really, really hard to play. I'm the developer and I cannot play it. Come on, man, I cannot even pass the first obstacle. Jesus, are you serious? To make it a little bit easier, we can reduce the amount of velocity we add to our birdie. So it's right now minus 500. We can make it minus 200, and we can make these guys a little bit faster, these obstacle things. So just change the speed of their rigid bodies to maybe 300 and make these spawn timer a little bit smaller. Okay, man, this is a lot harder than okay, maybe 200 is a bad idea. So where was it? Okay, maybe make it 350. Okay, this is much better. Woo, man. That's some skill shit. Dude, playing this really feels satisfying. But the only problem is that all these guys that are out of the screen, when they go out of the screen, they're still gonna be there. So we need to delete them, because if we don't, after some while, our game is gonna be super heavy. So how do we do that? Maybe we'll leave it for the next video. Okay, you should go try to do that, and I'll leave it for the next video. So this is it for now, guys. Thank you for watching. If you have any questions, just ask me. I'll jump off in the comment section and answer as always. And yeah, have fun.